Welcome to the Stormsurf video surf forecast of the week starting Sunday, March 31st. Looking at significant wave heights for the North Pacific Ocean, we see a gale producing 22-foot seas north-northwest of Hawaii, aimed pretty well at the islands. That'll make small swell, but there's far more interesting things behind that. Let's get into the details. As usual, we'll start our tour looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales. When those gales form, it helps direct their track. We're looking for a trough, a dip in the jet to the south, just like that right there. It's a little bit pinched. But what that does is that helps create like an eddy in the upper atmosphere and basically a counterclockwise circulation. That also manifests itself down on the surface, and that is the hallmark of low pressure, counterclockwise flow that is. And low pressure, if it's strong enough, generates winds. Winds generate seas. Seas as they radiate away from the fetch area turn into swell. Swell, when it hits your beach, produces surf. All right, so we have a little trough here that's capable of supporting low pressure, and as we saw in the previous chart, yeah, there's some seas up in this area, 22 feet, I think 23 feet, something like that. So good enough to produce a little bit of swell, likely heading towards Hawaii. But then from there, right about north of Hawaii, the jet splits with the northern branch going up into the Bering Sea, and you can see portions of it sliding down over America here. And it's the northern portion of the jet that has all the energy in terms of producing swell in the North Pacific. Southern branch, yes, it pushes, and it actually splits a little bit, pushing into Baja, but has no indications of doing anything to support gale development or swell production. All right, so we keep our eyes here on the West Pacific where winds are at, what is that, 1, 2, 3, 4, 3, I think it is. 160 knots, nothing super impressive yet. But as we get into Monday, winds build to 1, 2, 3, 4, 5. That's 180 knots. The pinch trough continues moving east, not really of any particular interest. But look at this. The split gets pushed well east over past east of Hawaii. That's a good sign. And that continues with the jet building into Tuesday night. Jet up to 190 knots in a little pocket there. Looks like a trough is going to start carving out in the Gulf, if you believe the models. As we get into Thursday, yes, just a little tiny trough here being fed by, 160, 170 knot winds. And that sort of pushes east. You can see it digging out more as it approaches the Oregon and North California coast on Friday, and then moving inland. Another weak little trough maybe behind that, but not a whole lot. But notice the jet is completely consolidated the whole way across the Pacific. You know, if this were October, something like that, we'd be going, hey, this is pretty interesting. But seeing how we're getting into April, yes, it looks good for producing some weather into California and maybe a gale or, you know, maybe two gales, but nothing super particularly interesting. And then wind energy really drops off. Still, the jet's holding together as we get into Sunday, and but still, weak energy flow. Would not be surprised to see the jet split at some point beyond that. And probably after that, storm production would drop off significantly. All right, let's go take a look down at the surface. Here we are, surface level wind, surface level pressure, and as we saw earlier, or at least expected, some sort of weak low, what is that, about a 988 millibar low northwest of Hawaii, generating 35 knot winds pushing towards the islands. So that's kind of interesting. Another little gale here trying to organize off of northern Japan. Both these systems kind of wind up a little, well, actually, the one off Japan winds up better, 45 knot winds as we get into Monday, while the gale north of Hawaii continues to hold, but it just kind of looks like it's going to get assimilated into this broader gale pattern, and by Monday night, that is in fact the case. Still, 40 knot winds approaching the dateline, good for swell production, but that one just doesn't really move anywhere too much. Another low tries to build while sneaking underneath that, so we call this like 1, 2, almost 3 low pressure systems, a complex gale pattern. And that system starts building as we get into Wednesday. There you go, 45 knot winds midday Wednesday. You can see it just under the tag there. 55 knot winds in the, we'll call it the western Gulf, northwest of Hawaii on Wednesday night. 55 knot winds, that's storm force winds, 50 knot even into Thursday morning, and 50 knot into Thursday night, approaching the U.S. West Coast. That should certainly generate some seas, and then you see the front pushing into the Pacific Northwest as we get into Friday morning, and then the gale starts basically just spinning out off of British Columbia Friday night. Maybe the models have been hinting at maybe some sort of follow-on secondary low building right behind it. This run of the model only shows pockets of 30 to maybe 35 knot winds. Oh, there we go. Winds up 45 knot winds Saturday night right off the Oregon coast. And then after that, well, we're at 180 hours. Maybe another gale developing. We know the jet is pretty weak at that time. No strong troughs. Probably not a whole lot to follow. All right, let's take a look at the effect of those winds on the ocean surface. Again, we already know there's 23-foot seas northwest of Hawaii associated with a little gale there, and they hold into Monday morning while the new system starts building behind it with 29-foot seas. It says 30 here, but really 29 for all practical purposes. But then 30 by midday Monday, holding in that range, producing swell. 28 feet, 27 feet as we get into Tuesday, and then it starts fading out. Swell for Hawaii and the U.S. West Coast is likely, nothing huge. And then we know a new, more energetic system starts developing later Wednesday. Seas building to 44 feet, going up from there 49 feet by late Wednesday night. 50 feet, supposedly. That seems awfully high given the relative non-super energetic state of the jet, but we'll go with it for the moment. 50-foot seas over a small area aimed east. Thursday into Thursday night, 45-foot seas. Pretty healthy system if this comes to pass, and even 42-foot seas just a bit off the California coast as we get into Friday. Of course, it appears that a bunch of weather is going to arrive about in sync with the swell front, but you get the idea. More spurious sea production behind that. This is mainly the core of it here. 27-foot seas as we get into Sunday, and then things start to settle down. Also, let's take a quick look at the southern hemisphere. It's really a little bit early in the season for that, but there is something to take note of. We're just going right to the wave model charts. We're in Monday, Tuesday. It is this system here. Tuesday, small system develops. Notice how retreated the ice line is here, way down at like 70 south. When we get into the peak of summer, which is the dead of winter in the southern hemisphere, this ice line will build the whole way up to about 60, maybe 62 south, something like that. But this time of year, the ice is well retreated. Any low that gets in this area can get traction on open ocean waters and produce some swell. So this guy gets up to 49-foot seas on Tuesday night in the southeast Pacific. Now the key here is, notice if you look at the wind model charts and do the same drill as you did for the North Pacific, all the winds are pretty much out of the west. This will target Peru, and mainly Chile, but maybe some side band energy will work its way up into California. 50-foot seas even into almost Wednesday morning, and then fading out. So Chile, for sure, if this forms, could get a good dose of long period swell. But after that, things settle down, and you just see for yourself. Pretty quiet after that, but maybe some swell for up into California. Probably not for Hawaii, but maybe for California and then locations south of there. Quick look at weather conditions, wind directions specifically. So here we are on Sunday, 18Z. Winds are out of the south in Hawaii. It was actually clean, and there's a little swell pushing into the north shore of Oahu this morning. But by this afternoon, winds were turning southwest, and it was getting pretty ragged on exposed breaks on the north shore. Not so good. California had a northerly flow. It was clean in North California this morning, but starting to get a little bit ruffled by afternoon. Nothing particularly of interest, though. Okay, we get into Monday. Still that kind of west wind pattern in Hawaii. Low pressure, very weak low building off California. South winds for Cape Mendocino, but probably a light flow near shore early for Central California. So we get into Tuesday, sort of a northeasterly flow for the islands, probably not clean on the north shore yet. And this front the low lingering off of the Oregon-California border, some sort of westerly flow, not too strong, but probably not particularly pretty either. Wednesday, California, finally, a little bit of weak high pressure builds in, light wind pattern generally. Hawaii, back into trades, finally things cleaning up on Wednesday. We get into Thursday. Light winds for California. Here comes that strong storm, 55-knot winds. Trades in control of Hawaii, and you can see the front already starting to build along the Pacific Northwest coast into Thursday. By Friday morning, south winds for all of Northern California down to probably the Golden Gate, but probably clean for all of Central California early, but by late morning, it's a south wind pattern in control there. Trade still in control of Hawaii. Saturday, then winds lighten up along the California coast. A light north flow, but as you get into Southern California, 15 knots, probably pretty bumpy by then. Another front queuing up for Sunday morning just for Northern California. And what's that look like? Light winds actually for California as we get into Sunday. Trades to northeast for the Hawaiian Islands. And that is it. So, first part of the week, not so great for Hawaii. Second part, looking much better. California, looks like a bunch of south winds. We'll take a look at the rain here in 2 seconds. But then maybe later in the weekend, things mellowing out a little bit. All right, taking a look at the rain situation. We're just looking at California here. Northern California, light rain as we get into Monday. And then that working itself down to the Golden Gate later Monday night. Maybe some snow for the higher elevations of the Sierra, but probably rain down low. We'll get details on that in a minute. And continuing into Tuesday, that fades out. A little bit of a break in the action, and maybe a glancing little dribble of rain, drizzle for Cape Mendocino Thursday. And then here comes the more solid of the fronts, pushing down Friday night to the Golden Gate. And from that is about 11 o'clock Friday night and down into, let's say, Morro Bay or so into Saturday morning. Then that clears out. A little bit more rain for Cape Mendocino area, but high pressure holding everything pretty much dry south of there. And that was 180 hours. So looks like 2 weather systems for the week for the bulk of California, and not making it really south of about Monterey Bay or so. Snow for the Tahoe area, total accumulation through Sunday the 7th, that's a week out. What are we looking at? Maybe 8 inches. And that, well, you can see it right here. So there's the bottom of Squaw. There's the top of Squaw. And the blue is where the actual snow events are. Probably all above about, there's 8,000 feet if you're lucky. And maybe even higher than that later in the week with a little bit of wind. Let's go take a look at Kirkwood real quick. Not even that much. What are we looking at? 6 or 7 inches. Kirkwood's higher though. Snow level, the base elevation 8,000 feet, but still you can see probably close to rain in the parking lot, snowing up higher lightly with some wind, but not bad. In Mammoth, we'll give it 3 inches. And again, the same situation, liquid precipitation probably even at the base of the resort. Got to get up higher to get actual snow. So it appears, and some wind of course, it appears that the snow season is winding down. All right, so let's go take a look at long term, what's going on with the MJO and of course El Nino. But seeing how it's getting to be pretty late in the season, the MJO has less effect on the jet stream and on the storm track, and of course the jet stream's weakening in the North Pacific about this time of year. As usual, we like to look at winds in the West Pacific. So this is the East Pacific here, West Pacific here. This is the equator. The date line's right there. That's New Guinea. And the arrows are, of course, wind direction. You see from the east, pretty solid the whole way across the Pacific, except south of the equator in the West Pacific. In the area we call the Kelvin Wave generation area from 135 east to about 170 west. Draw a little box 5 degrees north and south of the equator in this area. When you see west anomalies like we see, or west winds like we see there, that's a sign of the active phase of the MJO. And of course the active phase of the MJO, when it occurs, It's a cyclical thing, goes about 3 or 4 weeks in the West Pacific, making its way across the Pacific, and then goes into the inactive phase for 3 or 4 weeks. But when in the active phase, that helps impart energy to the jet stream. And then if the jet stream's goosed up, that helps feed the storm track and helps create storms. All right, anomalies, differences from normal for this time of year. Winds are stronger out of the east right here, and this is kind of important because we've noticed that sea surface temperatures are kind of dropping off in this area. They were quite solid a week ago and even maybe 2 weeks ago, and they've just been steadily getting eroded. We think it is because of these east anomalies, which have been in play for 4 or 5, even more a week now. But over in the West Pacific, west anomalies still in control, have been kind of nonstop for a year now. So that kind of is what helps sometimes if they're strong enough and last long enough to create El Nino. All right, so let's look at what's been going on wind-wise. Same deal. Here's the equator here. There's South America. There's New Guinea. Kelvin dateline right there. So Kelvin Wave generation area right here. When you see oranges and arrows from the west, that means westerly anomalies. This is CDAS 850 millibar wind anomalies, so up about 4,700 feet, but a good proxy for what's going on at the surface. West anomalies from the 25th of March, 26th, 27th, 28th, you get the idea. Steady westerly anomalies have been in play in the Kelvin Wave generation area. That is good. That helps take warm water that's here, push it to the east, and that is what helps create Kelvin waves. And Kelvin waves, if you get enough of them, help create a warm pool off of South America, and that's how you get El Nino. Here's zonal wind anomalies history and forecast from, we assume this is the GFS model. All right, so this is the whole planet on one chart. The date line runs right down the middle of the chart. You can see, oops, there you can see it right there. The Pacific Ocean runs from about here over to about here, but the Kelvin Wave generation area is right between these two tick marks going straight up. So when you see orange and reds, that's westerly anomalies. So March, when did it start? Oh, about the 8th or so. You see westerly anomalies non-stop, not particularly strong, but just steady for basically almost a month now. The whole, since March 8th to now, and our forecast to continue filling the Kelvin Wave generation area till the 5th of March. And then things start slackening off considerably. So one would say this is probably the active phase, the MJO in effect here. And it'll start dying in about 5 days to a week. This typically would be fueling the jet stream. And we've had some pretty good surf. We've had moments of sizable waves both in Hawaii and along the U.S. West Coast. And the active phase also helps fuel storm production in the southern hemisphere. There's been some small southern hemi activity during this window. Nothing super strong, but it's trying. All right, let's go out 2 weeks. This model is the outgoing long wave radiation forecast. Basically, that's a fancy way of saying where are there a bunch of clouds. But wherever there are a bunch of clouds, especially from the West Pacific, that could be a sign of the active phase of the MJO. Sort of looks like that's the case. It's sitting right over the maritime continent right now on March 30th. Per the statistic model, and are basically supposed to hold steady for the next 2 weeks. The dynamic model, basically the same picture, but those anomalies fading out and basically just going, we'll call it neutral. So basically in the West Pacific, Kelvin Wave generation area now is 135, so right along in there. Basically a dead neutral pattern per both models and staying that way for the foreseeable future. Phase diagram charts, just another way of pinpointing where the active phase of the MJO is. Assume you're looking down on the North Pole here, literally straight down on it. And the MJO moves from west to east around the planet on the equator, from the Indian Ocean over the maritime continent, across the West Pacific to the East Pacific, underneath the United States, and then across the Atlantic, into North Africa, back to the Indian Ocean. So this is where the active phase has been. The further away it is from the circle, the stronger it is. So this was back in March. In February. This was March, and ever since then, you see the active phase is just very weak hidden in this circle, going nowhere, and basically non-existent. Maybe that's a sign of El Nino, or maybe it's just a sign of a weak MJO pattern. That's from the statistic model. The dynamic model, the GEFS, saying basically the same thing. Very weak MJO signal right now. So we're just looking for any signs of the active phase of the MJO. Another way to look at it, and there's multiple ways, multiple dimensions for monitoring the MJO. This one now is, this model is areas favorable for precipitation. The green means favorable for precip. There's the equator right there, South America there, New Guinea right there. This is the Kelvin Wave generation area right there. Greens, meaning the active phase of the MJO, and it's supposed to, this is a 40-day model, so you start getting the feeling for the cycles of the MJO. You see the MJO moving out of the Pacific on April 20th. This is the inactive phase area, the yellows, not favorable for precipitation, moving into the West Pacific about mid-April, traversing the Pacific, and it pulling out of the Pacific on May 5th, and then a weak active phase following that, making it to the Central Pacific about May 10th. So active phase, inactive phase, active phase, the exact timing, you just look down here and look at the dates and you can figure it out for yourself. And yet one more drill down, the CFS model, 850 millibar wind anomalies. Again, whole planet on one chart, Kelvin Wave generation area, basically between these two tick marks. Looking down from January 5th, you can see this whole winter, it's just been non-stop westerly anomalies, helping to generate or feed the jet stream. Some of it was productive, some of it wasn't. We had definitely a dead zone from like mid-January into the whole way through February, and then finally things started waking up in March. More westerly anomalies, the reds are, here's the Kelvin Wave generation area. And the forecast for the next month, the solid contour is the active phase of the MJO, and we know that's weekly somewhere in the West Pacific right now. Forecast moving to the dateline over the next week with westerly anomalies. The next month with westerly anomalies still in control per this model. The other model suggests the active phase fading out. This one says for a whole month it's still supposed to be present. All right, enough of the MJO. We were trying to get to the 3-month model, but it is not working. There's some issue there, so we're just going to move on. All right, sea surface or subsurface temperatures. This is West Pacific here, East Pacific here. These are the anchor lines on the TAO buoy array, series of buoys strung across the equator used for monitoring El Nino. The X's are the actual sensors on those anchor lines. From this data and a little bit of fancy modeling, you can get a sense of what the temperature profile is. In short, warm water, 29 degrees in the West Pacific, 28 degree isotherm. This is kind of interesting. It was back earlier in the winter to about 160 west, but in the past couple of weeks has made a major eastward push to 137 today. And the 24 degree isotherm also holding steady, pushing into the Ecuadorian coast. But it is the anomalies, differences from normal for this time of year. What you see here, this is not particularly jumping out at you, but you see 2 to 3 degree above normal Celsius temperatures building or actually embedded in this warm flow of 1 degree greater than normal temperatures, completely filling the entire Pacific on the equator from west to east and going down 100 to almost 150 meters. So there's a river of warm water. Remember, we said there's been nonstop westerly winds blowing in the far West Pacific. Those warm waters, those westerly winds have taken warm water that was in the maritime continent, pushed it across the Pacific, and this is a Kelvin wave, a pocket of warm water tracking east, pushing into the Ecuadorian coast. Here's another view of that. This actually goes a little bit further off to the east. You see there's this little pocket, upwelling phase of the Kelvin wave cycle, basically almost gone and discharged along the Ecuadorian coast. Here is our Kelvin wave, much more pronounced in this model with 1, 2, 3, 4, 5, 6 1, 2, 3, 4, 5, 6. So up to 5 degrees above normal Celsius. Temperatures embedded in this with a follow-on pulse back here. The entire Pacific, and this is 1, 2, we'll say 3, 2-degree anomalies above normal. The whole Pacific has this giant pool of warm water trying to push east, trying to erupt on the ocean surface. You see it right there. Now, the only fly in the ointment is we have easterly anomalies blowing here. We saw that earlier. That sort of causes some upwelling. That's probably tapping this cool water, bringing it to the surface, and you'll see in a little bit what the issue is around that. Sea level anomalies basically tell us the same picture. This is JSON 3 satellite data. Strip out the wind waves, strip out the waves, strip out the tides. And basically it says when you see +5, +10 here, there's a bump on the ocean surface anywhere from 0 to 5 to 10 centimeters above normal. All that means is there's warm water at depth. Warm water down 100 meters expands, pushes the ocean's surface up just a little bit. You wouldn't see it if you were actually there, but the satellite senses it, knows it's higher than normal for this time of year. And all this means is there's a lot of warm water filling underneath the entire equatorial Pacific. Then this chart puts it into a historical perspective. That is, this is the West Pacific here, and you see time going down here. East Pacific here, you see a batch of warm water that pushed east. In April of last year, that was a Kelvin wave, and then it sort of dies. Upwelling phase of the Kelvin wave cycle, cool water off of Ecuador. Kelvin wave number 2, much stronger, went from basically the whole fall into Christmas time last year, erupted off the Ecuador coast. Then here's your upwelling phase. Cool water right now. And then here's Kelvin wave number 3, the strongest of all 3 of them. And it is poised, but not reaching Ecuador quite yet. Maybe another month, sometime late in April, maybe May, something like that. We should see the main effects of this Kelvin wave. All right, sea surface temperatures, specifically in the East Pacific. This is what we're interested in. So here's South America. That's Peru. There's Ecuador, Panama. You see cool anomalies right along the immediate coast here. Now, when we were talking about those east anomalies, we think that are blowing, or east winds blowing here, we think they're causing upwelling. They're taking the upwelling phase of the Kelvin wave cycle, the cool water, that pocket of cool water that was subsurface here, drawing it to the surface, but it appears to have already peaked and is fading some compared to days and weeks past. We still see warm water over the entire equatorial region, you know, up to 20 north and 20 south, except for this one little pocket here. Here's where those easterly anomalies are. We think if those easterly anomalies fade out, you're going to, and as that new Kelvin wave number 3 starts working its way into this area in the next 3 to 4 weeks, I think we're going to see a lot more warming right in here. It almost has that kind of El Nino-ish look too, kind of a triangle thing branching south down the American coast and up into Mexico, but not completely. And it's not strong warming at all, but in fact, this is cooler than it's been the past 2 weeks, 3 weeks, something like that. But still, certainly no signs of La Nina, and any kind of warming in this area tends to feed the jet stream a little bit, and maybe that will help us a little bit here, get some more, we'll call them spring swells in the near future. Sea surface temperature trend the past 7 days. A little bit of coolness right along in here off of the Galapagos, but not hard cooling. You know, a couple little scattered pockets of warming, but basically just kind of a dead neutral pattern. Yeah, it's warm. Actual temperatures are a little bit warm here, but no strong or explosive warming indicated, meaning the Kelvin wave has not breached the surface yet in any magnitude. But the overall trend, here again, those pockets of cool water along the immediate Peruvian coast and off of Colombia and just north of the Galapagos. But then this broad kind of warming trend setting up. It's, yeah, they're calling it El Nino, but it's not a strong El Nino by any stretch of the imagination. Just kind of a, we'll call it neutral biased warm. And that didn't, I mean, it looks better now than it did most of the winter, but it's kind of late in the game now to be doing anything in terms of fueling the jet stream because the North Pacific is slowly going to sleep here. And maybe this will have some positive impact on the southern hemi jet stream, but we'll see. A little bit early to make any speculations on that, too. Sea surface temperatures in the Nino 1.2 region, that's the area right there along Peru and Colombia and the Galapagos. You can see they're down. They've been holding down at minus a quarter of a degree, minus 0.259 degrees today. This is a rather noisy area, but the trend line generally has been down here, so there's no clear signs of El Nino or major Kelvin Wave eruptions of any duration along the coast in that region. Nino 3.4 index, this is the region from 120 west, so basically south of California on the equator out to almost the dateline 170 west, 5 degrees north and south of the equator, the official El Nino monitoring region. Temperatures there today, 0.7 of a degree, 0.711 above normal, and you can see they've been hovering at about half a degree or so above normal since January or so, and even longer. Officially, we're in some sort of a weak El Nino, but this is a very weak El Nino. If temperatures were up 1.5 degrees above normal, then that would be definitely getting our attention. But it has to be half a degree above normal before they even call it even remotely looking like El Nino, and we're just barely above that. So, in these weak El Ninos, they tend to not do a whole lot. It's better than La Nina. It's better than a weak La Nina, but it's not El Nino. But, it helps build some momentum in the atmosphere, especially if this goes on for a year or two or three. And we're kind of hoping that's what's going to happen. So what's going on in the atmosphere? Is it responding at all to the warm temperatures in the Pacific? Well, one index of that is the Southern Oscillation Index, difference in pressure between Tahiti and Darwin. When the pressure over Tahiti is lower than normal relative to Darwin, then the index goes negative. Today it's minus 8.47. As you look back in time, geez, it's been negative quite a bit for a very long time. In fact, the reality is it's been almost 2 months now. It's been steadily negative. So that sort of gives you a hint that, well, maybe El Nino is going on, at least an active phase of the MJO. 30-day average, that strips some of the noise out at minus 6.85. It was down to minus 15 or so at one point. So the active phase of the MJO probably fading a little bit. 90-day average, that's what you use for looking for El Nino. When you see it down around minus 11 or so, then you're in El Nino territory. Minus 7.55 today. So, yeah, not any legitimate El Nino that we would, and nothing that we'd call legitimate El Nino, but still, it's better than being positive and being La Nina territory. Let's take a look at another index. This is the ESPI index, sort of like the Southern Oscillation Index, but it's just different. Instead of difference in pressure north of Australia and over the equatorial Pacific, it's difference in rainfall, absolute rainfall, satellite measured average rainfall. And what we have today is the index is 0.39. Positive means there's a third of a standard deviation more rain here than normal, which isn't a whole lot. Basically just neutral, biased, a little bit wetter than normal. You can see that right out in here. There's where most of your rainfall is, towards the date line. So that would be more like a Modoki El Nino rather than, and you see it's drier, or yes, that's drier here over in the far East Pacific. Really want to see, if you're in real El Nino, you want to see the rainfall out here. We're not there, but it's not La Nina. And then finally, the forecast from for the Nino 3.4, the official El Nino monitoring region, sea surface temperatures. Today, the model says we should be about 1 degree above normal. We know we're, about 0.78 or something like that. So, not too far off. The forecast has sea surface temperatures warming, presumably as that Kelvin wave number 3 erupts. Temperatures building into July, peaking at 1.4 degrees above normal. If this was in December, we'd be kind of interested. This would be, okay, great, that's perfect, syncs up with El Nino. But instead, as we start working our way into the fall, temperatures slowly slide down to 1.1 degrees, and as we get into almost December, 0.9 degrees, which probably isn't a whole lot different than where we are today, but we will have had 2 years of momentum building behind it. So the thought is next fall, by next fall we're talking what, 5-6 months out, probably a little bit more energetic storm track than what we had this past year. And hopefully it will hold as we get into winter, though it sort of looks like sea surface temperatures might be sliding down from there. Hard to tell. We'll say average to slightly above average projection. Now, the other good news, though, here is it was sea surface temperatures rising. Maybe this will feed the jet stream for the southern hemisphere the summer time frame. So maybe a better summer than normal for California and Hawaii. A little bit too early to know, but maybe. Seems that's possible. So for the immediate future, series of swells look late season swells. We'll take them from the North Pacific for Hawaii and the U.S. West Coast. A little bit of weather involved, a little bit of not so good winds as well. But hey, you take what you can get. It's better than nuking north winds, as typically happens in the spring. And with this El Nino-ish kind of pattern, we suspect that will dampen high pressure, the Northeast Pacific high, and maybe make it so it's not a wind-blown mess as it usually is in April. The La Nina years are the worst of the worst. High pressure is amplified way above normal, and it just is blowing and cold in California. Anyway, so after that, maybe a little southern hemi swell too. Hard to say. Strong storm forecast, something to watch. And then beyond that, summer, the forecast looking, pretty good. Average or better than average is the expectation right now. We'll give it a 6 or 6.5, something like that. But we said the same thing for the winter, given the El Nino situation, and it didn't quite materialize. It sure did snow-wise, but not so much surf-wise. And then long-term, looks like we're going to be in a pretty decent place, average or better than average for the next year. I mean, we're talking into the winter of 2019-2020. That's what the forecast looks like. So enjoy what you can get, make the most of it. We're in a pretty good place here. And we'll keep our eyes on the data, and we'll do this again next week, same time, same channel. Thanks for watching.